The research paper introduces a multidimensional evaluation framework for natural language generation, NLG, using in-context learning with large language models. This approach eliminates the need for large training datasets and achieves state-of-the-art performance in dimensions such as relevance and factual consistency, making it competitive with learned evaluation frameworks for text summarization. The authors investigate the impact of factors like the selection and number of in-context examples on performance, as well as the efficacy of the evaluators in evaluating zero-shot summaries written by large language models. The framework is learning-free, requiring only a few samples at inference time, and can be extended to new dimensions without needing large amounts of human judgments or synthetic data. This innovative approach offers significant advancements in NLG evaluation, providing a more efficient and flexible method that does not rely on extensive training data. It also opens up opportunities for further research into the capabilities and limitations of large language models in generating high-quality summaries. In the realm of text summarization, evaluating the quality of system-generated outputs is a crucial task. This research paper explores the application of in-context evaluation, ICE, a methodology that leverages large language models to make predictions on the quality of summaries. The authors demonstrate ICE's competitiveness with state-of-the-art trained evaluators in multidimensional evaluation, establishing a new state-of-the-art on dimensions such as relevance and factual consistency. The ICE framework outputs a score that captures the quality of a system-generated output sequence, with or without a human-generated reference output. This multidimensional evaluation assesses the output sequence over diverse quality metrics, including consistency, relevance, fluency, and coherence. The ICE methodology relies on a large language model, LLM, to make predictions, using input prompts that consist of in-context examples, each comprising generated text and its corresponding quality score, followed by a test example for which the model predicts a score. The authors analyze the factors affecting ICE's performance, finding that it is robust to the selection of in-context examples with a slight improvement in performance as the number of examples increases. The number of in-context examples and sampling procedures are identified as key factors influencing ICE's performance. The research highlights the potential of ICE as a competitive evaluation framework for text summarization, with implications for improving the quality of system-generated summaries. The authors present a meta-evaluation framework for assessing the performance of various metrics in summarization systems. They utilize the SumEval dataset, which comprises 1,600 summary-level annotations for 16 summarization systems on 100 articles from the CNN, Daily Mail corpus. The dataset is divided into a test set of 1536 examples and a small subset of 64 examples for in-context examples. The authors compare their proposed framework, ICE, with state-of-the-art multidimensional evaluators, including CTC, BART score, and Uni-Eval. ICE is competitive with fine-tuned baselines despite not requiring any fine-tuning. It achieves state-of-the-art correlation with human judgments for relevance and consistency. The results, as illustrated in Table 1, show that ICE outperforms Uni-Eval on consistency and relevance on Kendall's tau with a significance level of 0.05. Additionally, the uniform sampling variant of ICE outperforms BART score across dimensions. The authors also analyze the effects of their prompt engineering choices, including the comparison between uniform and stratified sampling procedures. They observe that uniform sampling causes in-context examples to have near-perfect scores for consistency, leading to better performance. In contrast, stratified sampling works marginally better for all dimensions other than consistency. The analysis also explores the distribution of scores for fluency, coherence, and relevance, and how they are affected by the sampling procedures. The authors find that fluency scores are quite stable, possibly due to the model possessing a strong notion about fluency from pre-training time. The performance for coherence and relevance is similar regardless of the sampling procedure, as scores for these aspects are spread out in the dataset. Overall, this page presents the experimental setup, results, and analysis of the proposed ICE framework, highlighting its competitive performance with state-of-the-art evaluators and the effects of prompt engineering choices on its performance. The page emphasizes the significance of sampling in evaluating the consistency, fluency, relevance, and coherence of generated summaries. It distinguishes between uniform and stratified sampling, with uniform sampling being more suitable for selecting in-context examples due to its stability and ability to closely follow the true distribution. The text also investigates the robustness of performance to the choice of in-context examples and the effect of varying the number of examples. Figures and tables demonstrate that while performance is generally stable, there are slight improvements in relevance and coherence with increased sample sizes. The table on page 5 presents system-level scores from human annotations and automatic metrics, showcasing the performance of various models, including human GPT-3, Brio, and T0, across different aspects such as coherence, fluency, and relevance. ICE GPT-3 achieves the highest scores in most aspects, closely followed by Brio and T0. Notably, the scores for coherence and relevance are spread out, suggesting that a larger sample size allows for better representation of the entire score range. The model's performance reaches near that of some weaker fine-tuned baselines even with a single in-context example, implying that the model possesses knowledge of the evaluation task from pre-training itself. Calibration can potentially be improved by increasing the number of examples, as demonstrated by the concentrated prediction distribution observed in the coherence evaluation. The study also investigates the efficacy of ICE in evaluating zero-shot summaries written by GPT-3 at a dimension level, showing that ICE agrees with human judgments for each dimension and overall. The paper explores the application of iterative context enhancement, ICE, for text summarization, specifically focusing on benchmark meta-evaluation suites. It delves into this dimension and its implications on downstream tasks, reserving further investigation for future work. The authors reference several. The authors evaluate the performance of their proposed in-context evaluator, ICE, on the SumEval dataset using a carefully designed experimental setup. From the dataset, they randomly select 4 articles, each with a single system-generated summary serving as an in-context example, ensuring no overlap with the source articles of the test examples. The remaining 1536 examples constitute the test set. 2 sampling procedures are employed to select in-context examples: uniform random sampling and stratified sampling. In uniform random sampling, one summary is randomly picked from the 16 summaries for a given source text. Stratified sampling divides the summaries into 4 buckets based on their scores on the aspect of interest, selecting one summary from each bucket, each from a different source text. The authors annotate the summaries using a 1 to 5 scale for coherence, consistency, fluency, and relevance, following Fabry et al.'s 2020 annotation instructions. Existing packages are used for baselines, including Rouge, BART score, CTC, and UniEval. The results of the experiments are reported in Section 5. To compare ICE's performance with UniEval, pairwise significance tests are conducted using 1,000 bootstrap samples, with 80% of the test set randomly selected for each sample. The results show that ICE with uniform sampling outperforms UniEval on consistency and relevance at a significance level of 0.05 using Kendall's tau, and on consistency using Spearman's rank correlation.